Okay, so the world of AI and large language models is just absolutely exploding, right? New tools, new trends popping up daily. And, for us Python developers, it's incredibly thrilling. But let's be honest, it can also feel a bit overwhelming. The headlines promise everything, AI writing 90% of your code, AGI around the corner. But what's the real picture? What's genuinely going to help you, a curious Python developer, actually stay ahead?
Yeah, that's exactly it. And that's precisely our mission in this deep dive. We're really here to cut through all that noise, all the hype. We'll extract the most critical insights, the practical advancements that are relevant to you, whether you're just starting out or you're, an intermediate Python developer. Our goal is to give you a clear, sensible path, a way to navigate and actually leverage these powerful technologies, especially when you're trying to build reliable production-ready applications. This isn't just about, oh, what's shiny and new. It's about what's impactful for your success, giving you a solid roadmap for what to focus on, like right now.
That is exactly what we need, a roadmap. We've gathered insights from industry experts, leading developers, even the founders of some of these cutting edge tools. So, okay, let's unpack this. Let's find out what's truly a game changer and, frankly, what might just be clever marketing.
Right. And what's truly fascinating when you look closely at the landscape of LLM applications, it isn't really the buzz around agents that supposedly think for themselves. The reality, many, maybe even most, production LLM applications aren't truly agentic in that mystical sense. They are fundamentally well-engineered software. The big shift in thinking, the really important part, is to apply established software engineering principles to these LLM-based applications. We need to move beyond treating LLMs as some kind of, I don't know, magical black box you just talked to.
Okay, so if they're not magic and they're really software, how do we build them reliably? I've heard this term 12-factor agents floating around. Is that where the rubber meets the road for reliability? Is that the key?
It absolutely is, yeah. That framework, which is inspired by Heroku's, super widely adopted 12-factor app methodology, it really rethinks how we build reliable LLM apps from first principles. It emphasizes these modular concepts that, crucially, you can apply even to your existing code bases. That makes it incredibly accessible, right? Even if you don't have a deep AI research background. Think of it as, well, best practices for this new generation of software. And here's a critical insight, maybe even a bit surprising. The most magical LLM capability, the thing that enables so much, it often has nothing to do with complex reasoning loops or, elaborate tool use. It's simply turning natural language into structured data, like JSON. That seemingly simple act. It's the bedrock. It's fundamental for building intelligent applications.
That sounds almost counterintuitive. Like, really, just JSON. I've even heard a pretty controversial take that tool use is harmful. What's behind that perspective? Especially when giving LLMs access to tools seems like, well, the key to building powerful agents.
Right? It's a nuanced point. It's not really about saying elements shouldn't use tools. Tool use is incredibly powerful, no doubt. The harmful perspective is more about the mindset. Treating tool use as this sort of magical interaction, like you're talking to some ethereal alien entity, that could be really misleading. It often leads to brittle, unreliable systems. In reality, what's happening? It's an LLM outputting structured data, usually JSON, which is then processed by your deterministic code. It's software interacting with software, plain and simple. And this leads directly to a crucial point for building reliable apps. You must own your control flow. Traditional software relies on directed acyclic graphs, DAGs, think about your basic if statements, or more complex orchestrators like Airflow. Now, while agents often promise to kind of find their own path, especially in long workflows or with huge context windows, they frequently fail. They fail precisely because that emergent behavior is just hard to control. True reliability comes from explicitly defining your agent's inner loop. How it picks the next step, using clear switch statements for model output, carefully managing its context window, and having explicit exit conditions. You need that structure.
And this isn't just about the agent's logic, the control flow, is it? It's also about managing its state, right? Like standard APIs need state management, so agents must too.
Exactly. Just like any standard API or service, agents need to manage their execution state. Things like, retry counts if a tool call fails. And also the business state. What messages has the user seen? What data is being processed right now? Owning this state is what allows you to, say, pause and resume workflows. You can even serialize the context to a database if needed. It really hammers home the point.
Yeah.
These agents are software. Treat them like software. Apply those robust engineering principles.
Okay, that makes sense. Treat it like software. Own the control flow, own the state. Building on that, then, what skills should developers be focusing on?
Well, building on that, probably the hottest skill in AI right now, the one everyone seems to be looking for, is something called context engineering. This is really the art and science of feeding just the right information, in the right format, into the LLM's context window. Just enough so that the task becomes, well, plausibly solvable for the model.
Yeah.
It's all about building dynamic systems that adapt, not just writing one static instruction set and hoping for the best.
Right. We've all heard about prompt engineering for ages now. How is context engineering different? Like, what's the next level aspect here? Why is it such a crucial shift for us developers?
Yeah, good question. Prompt engineering often focuses on crafting that perfect initial instruction, right? Context engineering takes it, well, quite a bit further. It's about dynamically populating that context, adapting it based on changing data, the tools available, the flow of the conversation, or the workflow. It's essentially an extension of prompt engineering, but for a much more dynamic, interactive environment.
And here's where it gets really interesting and frankly critical for building robust systems. Understanding the context failure cases. Knowing how context can go wrong is key. There are a few major ones you absolutely need to watch out for. First, there's context poisoning. This is nasty. It's when hallucinations or just plain errors creep into the context. And then the model keeps referencing them, leading to totally irrational behavior down the line. Imagine the LLM insisting on a fact that was subtly wrong early on, and then building its whole argument on that shaky foundation. We saw this with that Gemini Pokemon example that went around.
Oh, right. Yeah, I remember that. Okay. Second, context distraction. This happens when the context just gets too long. The model starts over-focusing on all that context history and kind of forgets its core training or gets stuck in loops, repeating actions. Think of a coding agent constantly trying to fix a bug that isn't even real, just because the description is buried deep in a huge context window. And this distraction ceiling, it can be much lower for smaller models. Like Llama 3.1405B, even though it's huge, could start to struggle significantly around 32,000 tokens.
Wow, 32K isn't even that massive compared to what some models claim. Okay.
Exactly. Third is context confusion. Basically, just too much irrelevant stuff in the context leads to low-quality responses. This happens a lot when you give the model too many tools. Studies show performance often degrades with more than even one tool active. Practically speaking, maybe 10 to 15 tools seems to be a common functional limit before things get confusing for the model.
Only 10 to 15. Okay, that's important to know.
And finally, context clash. This is when new information directly conflicts with stuff already in the context. This can lead to dramatically worse results, especially if you're feeding instructions in chunks over multiple turns. Performance can drop by up to 39% in some cases. The model just gets tangled trying to reconcile conflicting data.
Okay, wow. Poisoning, distraction, confusion, clash. That sounds like a minefield for building anything reliable. So what are the practical strategies? What can we as developers actually do to fight these context catastrophes and build more resilient systems?
Excellent question. And yeah, it sounds daunting, but the good news is there are concrete strategies. We have tools. First, retrieval augmented generation, RCE, we mostly think of it for search, right?
Yeah.
But it's broader. It's about selectively adding only the relevant information to the context. For instance, back to the tools example. If you have 50 tools defined, RIG can help dynamically select maybe the 10 most relevant ones based on the user's query. That prevents context confusion right there.
Ah, using RG for tool selection. Smart. Okay.
Then there's context quarantine. This often involves isolating context in dedicated threads. Think multi-agent systems, handoffs between specialized agents. It's like creating separate sandbox environments for different parts of a task, so context doesn't bleed over inappropriately.
Like firewalls for context. Got it.
Sort of. Then context pruning. This is about actively removing irrelevant or simply unneeded information. You might re-rank retrieved data chunks and just discard the less useful ones, or even use specialized models like provenance that are designed specifically to identify and remove noise from context.
Okay, actively cleaning it up. Makes sense.
Context summarization is another one, especially crucial for long conversations. Boiling down the history into concise summaries. But the trick here is you have to summarize only the relevant bits. A bad summary can introduce its own confusion.
Right, summarizing the right things.
And finally, context offloading. This means storing information outside the LLM's immediate context window, maybe in a database or temporary store, and managing access via tools. This is absolutely key for building effective short-term and long-term memory systems for agents. Let the LLM query for info when needed, rather than trying to hold everything in its head. So, the bottom line, if you really want to push past a certain quality bar, get that reliability. You need to own your prompts and how you build that context. Every token matters. Remember, LLMs are pure functions, tokens in, tokens out. Optimizing the density and clarity of the information you pass in. That's paramount for getting high-quality, reliable output.
That's a great overview of managing context. It really feels like the engineering side of things. Okay, shifting gears slightly. Well, LLMs get the spotlight. You mentioned RGA, and for that, embeddings are crucial, right? They're the unsung heroes. I've heard about a new one making waves, Gina embedding v4. What's special about it?
Yet embeddings are absolutely critical, and Gina v4 is a really impressive example of where things are heading. It's super versatile. First off, it's multimodal. It understands both text and images. And it's multilingual, handles, I think, 29 different languages. Crucially for us, you can use the same model for both regular text retrieval and for code retrieval. That's huge. Its architecture is pretty clever. It uses a vision decoder for the images and then a shared language model decoder for both text and images. And here's a really smart piece of engineering. It includes dedicated LoRa adapters. Think of LoRa like these tiny, specialized expert modules you can plug into the main model. They make it incredibly good at specific tasks like finding similar code snippets or classifying text without needing to train a whole new massive model each time.
Ah, so specialization without the massive overhead. Nice.
Exactly. It also offers flexible output. You can get standard fixed-size dense embeddings or these more complex multi-vector representations. Gives you control over storage versus accuracy trade-offs. And then there's this really neat trick called matryoshka embeddings. Imagine Russian nesting dolls, but for your data representation. The same model can give you a super high detail embedding or a more compressed, smaller one if you need speed or lower cost. You can get embeddings of different sizes, from 128 dimensions up to over 24,000, just by deciding how much detail you need and truncating. It saves potentially huge amounts on cost and speeds things up. Plus, it supports a long context window up to 32,000 tokens. That makes it really suitable for techniques like late chunking, where you keep the global context intact while still getting fine-grained chunk-level embeddings.
Okay, so why this matters so much for you, the Python developer listening. This means you might not need, 5 different embedding models for different data types or tasks. You could potentially use one really good one, like Gina v4, simplifying your RH pipelines, your coding agents, everything. That translates directly into real performance gains and, importantly, cost benefits. Makes your life a whole lot easier when building these AI apps.
Absolutely. And moving on to the actual developer tool landscape, well, AI-powered coding tools are evolving at an incredible pace. It's almost hard to keep up. We're seeing IDEs and agents that are, fundamentally changing how code gets written, from the first line to review, even to fixing bugs autonomously.
So who are the key players here? What are some of the standout tools in this rapidly evolving landscape? Where should developers maybe focus their attention right now to get a real edge?
Great question. There are several worth highlighting. One is Refact AI. It's actually an open source AI software engineer. It ranked #1 on the Swaybench Verify test, which measures autonomously resolving real-world engineering tasks. So it's got proven capability, integrates directly with VS Code, JetBrains, offers real-time coding help, diffuing, file rollbacks, supports lots of different LLMs too, GPT-4o, Claude 4, Gemini 2.5 Pro, even custom APIs.
Open source and top ranked. That's compelling.
Definitely. Then you have things like Cloud Code from Anthropic. It's a command line interface that's apparently seeing massive adoption, both inside Anthropic and externally. And its open source competitor, Open Code, is also gaining traction. A big draw there is its support for local models, like Devstral Small. This really addresses that crucial need for cost-efficient, self-hosted solutions, right? Especially given the rising costs and sometimes controversial pricing changes we've seen with proprietary APIs like cursors.
Yeah, local models are a big deal for cost and privacy.
For sure. And don't forget Amazon Q Developer Pro. It's known to be highly effective for AWS-related coding inside Amazon, obviously, but it's now accessible to external developers too. Worth checking out if you're in the AWS ecosystem. But maybe even more significant, kind of happening underneath the surface, is the Model Context Protocol, or MCP. This is a major trend, open-sourced, driven initially by Anthropic. What it does is allow AI agents and IDEs to connect to and interact with all sorts of diverse data sources, databases, GitHub, Google Drive, internal company APIs. You name it. Amazon being API first for, 20 plus years now, they're apparently rapidly adopting MCP internally for massive automation. Think workflows, ticketing systems, internal knowledge bases. This is a fundamental shift you really need to be aware of. It enables a whole new level of interconnectedness and automation potential for AI agents.
Wow, MCP sounds like the plumbing for truly integrated AI workflows. Okay, so beyond these individual tools, you mentioned workflow. The real power comes from orchestrating them, right?
Yeah.
Making them work together.
Precisely. It's about maximizing your output by having multiple things running in parallel. And there's this really creative approach some folks are using. They call it the senior dev intern CEO workflow. It's kind of fun.
Senior dev, intern, CEO. Okay, tell me more.
So imagine this. You use a powerful coding assistant, like Claude Code, as your senior developer. Inside your IDE, maybe Cursor. It does the main heavy lifting, scaffolding the core logic. But simultaneously, you spin up several intern background agents, also maybe in Cursor or similar tools. These interns handle smaller, more specific tasks in parallel. Things like adding visual decorations to a UI element, implementing model pickers, running security linters, maybe even drafting a basic marketing plan for the feature. Now, here's the really clever part. During the inevitable downtime, when your coding AIs are thinking you're generating code, you switch context and engage with a CEO AI, maybe Claude Opus or GPT-4. You use that time for higher-level strategic thinking, building roadmaps, discussing monetization options, maybe even getting career advice related to the project. This workflow maximizes your efficiency. Multiple AI agents work concurrently, and you turn what used to be unproductive waiting time into valuable strategic planning. It's like having a whole mini-team managed by you.
That workflow sounds, honestly, kind of wild, but incredibly efficient, like running an AI-powered micro-agency from your keyboard. But okay, to actually build these interconnected systems, especially beyond just one developer's setup, we often need orchestration frameworks, don't we?
What are the key players developers should be looking at for building these more dynamic, multi-step LLM applications?
Exactly. For building robust, dynamic, interconnected LLM apps, frameworks are pretty much essential. LangChain is probably the most well-known example. It's open source, Python and JavaScript libraries available. Acts as the glue for LLM applications. It provides all these modular components, prompt templates, chains for sequencing calls, tools for interacting with APIs to connect LLMs to your data, external tools, and application logic. It's fantastic because it supports using multiple different LLMs within a single app, leveraging the best model for each subtask, and it's growing incredibly fast, huge community.
LangChain, right. Heard a lot about that one. Then there's N8N. This is another really powerful open source tool, but it's more visual. It's a workflow automation tool. Allows you to build complex AI workflows by dragging and dropping nodes, connecting everything from Google Sheets to ChatGPT to Slack to your own APIs. A huge advantage of N8N is its self-hosting option. It follows kind of a WordPress.org model. You can run it on your own infrastructure, which can offer significant cost savings, especially for complex or high-volume automations. These frameworks, LangChain, N8N, and others, they're what lets you integrate LLMs into truly complex systems, automate multi-step processes, leverage the unique strengths of different models. It's really about building out full-fledged solutions, not just isolated chatbot prompts.
Okay, frameworks like LangChain and ANN for building, but what about just experimenting, getting hands-on? To truly experience the frontier, you should probably check out something like Google AI Studio, right? It offers a free integrated platform to play with their Gemini models, Pro, Flash, Gamma.
Absolutely. Google AI Studio is a fantastic playground, and more than just a playground, really. Within it, you got some serious capabilities right at your fingertips. You can easily switch between Gemini Pro, that's the one for complex reasoning, multimodal tasks, and Gemini Flash, which is faster, cheaper, great for more agentic use cases where speed matters. They also have the Gamma models, which are free, though maybe with slightly older knowledge cutoffs and a bit higher latency. You get really fine-grained control over the generation process. You can set a thinking budget for reasoning tasks and force structured output like JSON, super useful enable code execution for running scripts, and leverage function calling to interact with external APIs. It also has powerful grounding capabilities. You can connect the LLM's responses to real-time information from Google search or specific URLs, making the answers much more current and factual.
The grounding sounds really useful. And what about the more interactive features?
Yeah, the streaming features are amazing. You can interact with Gemini using your voice, your webcam, like hold up an object and ask it what it is, or even share your screen. Imagine debugging a tricky UI issue by just sharing your screen and having the AI analyze it, or asking it to summarize a document that's currently open. It's incredibly powerful for interactive workflows. And if you're feeling creative, you can even generate AI music, images, and video directly within the studio. It's becoming a real multimedia creation hub, too.
Wow, okay. Screen sharing, webcam input, that's pretty next level interaction. So these general purpose AI studios are great for exploring, but we're also seeing AI get really powerful when it's specialized, right? Solving specific problems in niche areas. Things like Perplexity Finance and Retriever AI seem like great examples of this trend AI tailored for specific verticals.
Indeed. That's where a lot of the immediate value is being created. Perplexity Finance, for instance, is a dedicated section within Perplexity AI. It's got a whole suite of tools specifically for financial research. We're talking SEC API access for developers, real-time stock prices, company financials you can download, earnings call transcripts. They have this feature called Perplexity Spaces where you can ask questions across preloaded data sets like all S&P 500 transcripts. Super useful. And their deep research tool basically acts as an AI agent to generate comprehensive reports on financial topics. Apparently, it's even used by big-name financial folks like Howard Marks and Stanley Druckenmiller, which, tells you something about its utility in that demanding field.
High praise indeed. And Retriever AI, that one sounds interesting too.
Yeah, Retriever AI is different. It's a free, local-first browser extension. Its focus is automating complex web-based tasks, things like scraping data across multiple sites, filling out complex forms, even applying for jobs online. It can do this across multiple browser tabs in parallel. Reports suggest it actually outperforms many other web automation agents in both success rate and speed. And because it runs locally and leverages free Gemini API keys, it offers really cost-efficient web automation.
Free and local first, that's a compelling combo for automation. So what does this all mean for you, the listener? These examples really drive home that AI isn't just about general-purpose chatbots anymore, not by a long shot. It's about specialized agents, tailored tools solving real-world, often high-value problems in specific contexts. It's about putting AI to work where it can have the biggest, most tangible impact on your specific work and the projects you build.
Exactly. But now, let's have a bit of a reality check. Because we need to be sensible here, right? While you hear executives making bold claims, maybe AI writing 30%, 50%, even 90% of code, the reality on the ground often shows struggles. Bugs introduced by AI, failed fixes, integration headaches. However, there's a really significant underlying shift happening. Experienced engineers, the folks who've been coding for years, who know the pitfalls, are increasingly enthusiastic about these AI tools. They see the practical benefits when used correctly. They're the ones driving the most successful adoption stories. We're not here to sugarcoat things. AI isn't perfect magic, but its trajectory, its potential impact, that's undeniable.
That's a good dose of reality.
Yeah.
And it always leads to the big question, the elephant in the room, is AI going to replace us? Replace software engineers? What's the sensible truth here?
Yeah, the replacement question. The sensible truth, based on everything we're seeing, is that AI is not replacing software engineers. It's transforming the role, fundamentally transforming it. Routine coding tasks. Yes, those may well be increasingly automated. That seems likely. This leads to a profound shift. You move from writing every single line of code yourself to orchestrating AI-generated programs. You become more of an editor, a reviewer, an architect of the overall system, rather than solely a line-by-line coder. And this transformation, it brings key changes, but also huge opportunities. Some experienced engineers genuinely report massive productivity boosts, like 10x, even 20x, though broader surveys show maybe a more modest but still significant 3 to 5 hours saved per week for the median developer. That's still valuable time back.
Okay, so a transformation, not a replacement, and tangible productivity gains.
Right. And what's more, the specific language or framework, starts to matter a bit less. AI assistance makes it genuinely easier to switch between technologies to pick up new stacks. This allows engineers to be much more versatile, more adaptable. Some veterans, people who've seen major shifts before, they compare LLMs to the leap from assembly language to high-level languages like C or Python. A similar kind of step change in productivity, but with this added, tricky complexity of non-determinism that we have to manage. This shift also totally changes the cost landscape. Things that used to be considered incredibly expensive or difficult computationally. Some of them are now, frankly, ridiculously cheap thanks to these models. It opens up entirely new possibilities for what you can realistically build.
New possibilities because the cost structure changed.
Interesting. And looking even further ahead, we're seeing early experiments with things like self-adapting LLMs or SEALs. These are models that can actually generate their own training data, they call them self-edits, and use that data to improve their performance on specific tasks, like incorporating new knowledge or getting better at few-shot learning. Now, it's still very experimental. They face big limitations like catastrophic forgetting, where improving one skill makes them worse at others. But it definitely indicates the trajectory, right, towards more autonomous AI improvement.
Okay, so things are moving incredibly fast. For you, listening right now, a Python developer trying to navigate all this, what's your guaranteed path to success? Based on everything we've dug into today, what should you really be focusing on to thrive in this new landscape?
Right, the guaranteed path. Maybe not guaranteed, but here's the most sensible, reliable path to success we can see in this evolving landscape. First, upskill continuously. Don't let yourself get pigeonholed into one narrow skill set. Become more of an expert generalist. Be adaptable across different technologies and approaches. Second, Master the AI tools. Don't fight them. Learn to work alongside them effectively. Become really adept at prompting, at orchestrating different AI components, and crucially, at meticulously reviewing and debugging AI-generated output. Your value shifts from just writing code to curating high-quality, reliable systems. Third, focus on uniquely human skills. Things like empathy, clear communication, leadership, strategic thinking, understanding the why behind the software. These become even more critical. AI might handle more of the how, but you define the why. Fourth, embrace experimentation. This field is changing weekly. You have to try things out, see what works for you, what doesn't. Understand the new cost paradigms, figure out when self-hosting something like NAN makes sense, or when leveraging the free tier of Google AI Studio is a smart move. Be practical and curious.
And finally, maybe most importantly, master its fundamentals. Strong coding principles, solid software architecture skills, good debugging techniques. These are more essential than ever. You need them to understand and fix AI's inevitable mistakes, to build robust, complex systems on top of these powerful but sometimes unpredictable new tools.
That's a fantastic summary. Expert generalist, master the tools, focus on human skills, experiment, and double down on fundamentals.
Yeah, I think that covers the core of it. The landscape of software development really is undergoing a fundamental shift. LLMs aren't just another tool in the belt. They represent a genuine step change in how we build things. And the biggest success stories we're hearing, they're coming from engineers, often experienced ones, who are embracing this change, who are experimenting relentlessly, and who are treating AI not as magic, but as an incredibly powerful co-pilot.
So your path forward as a Python developer really involves understanding these core ideas we talked about, owning your control flow, mastering context engineering, leveraging powerful new embeddings, orchestrating AI agents effectively. Definitely experiment with the tools we've discussed today. Check out Refact AI, play with Google AI Studio, explore frameworks like LangChain and N8N, get your hands dirty.
And maybe the final thought to leave you with is this. What problems that maybe you previously considered too complex, too time-consuming, or just too expensive to solve? What problems can you now tackle with these incredibly powerful and increasingly accessible AI tools? What new possibilities are open to you right now?
That's a great question to ponder. Keep learning, keep adapting, and definitely keep building. This deep dive was really just scratching the surface of what's possible for you.